Hi.
Hello, Mr. Chairman.
I want to introduce Professor Lehert. And Professor Philippe Lehert is Belgian scientist specialized in mathematical statistics and biostatistics applied to the drug development and health management. Master of Science and Doctor of Computer Science from École Polytechnique 1974, Belgium. He was awarded a PhD at the Statistical Department of the Faculty of Sciences, Mons, Brussels, Belgium, for his seminal research on the computational complexity of clustering algorithms in hyperspaces. I admit with respect, honestly, that I don't know what is this branch of science, but I repeat, the PhD research of Professor Lehert, seminal research on the computational complexity of clustering algorithms in hyperspaces. Professor Lehert currently holds position as Honorable Professor at the Faculty of Medicine, the University of Melbourne, Australia from 1996, and Department of Statistics in Faculty of Economics, University of Leuven, Mons Leuven, Belgium from 1978. He has held numerous elected and honorary positions, including member of the Belgian Statistical Steering Committee, Scientific Director of International Health Foundation, Geneva, Switzerland, Senior Consulting Statistician for the United Nations and World Health Organization, Switzerland, former Consulting Statistician for the European Medicine Agency, London, UK, and Food and Drug Administration, Washington, D.C. Review editor for 8 scientific journals and reviewer for the Cochrane Review Group. It is an honor for me to present you Professor Lehert would lecture how to predict the probability of live birth before IVF ICSI attempt for a poor ovarian responder at the first visit of the couple. The floor is yours, Professor Lehert.
Thank you very much for this invitation. And before all, I'm very far from you because I'm here in Melbourne where the temperature is 25 degrees Celsius, which is probably not the same in Sofia. And I'm just here, and let me justify my presence here. I'm chairman of the Department of Statistics, and I'm not a gynecologist at all. Chairing the Department of Statistics, we receive a lot of different, that's okay, I see the presentation here now. I receive very often questions from the Faculty of Medicine in a lot of different areas. And one particular question I received last year and 2 years ago was from the people interested by art, by artificial reproduction technique. Is it possible to predict live birth when you receive a couple with subfertile? And the question is, how many chances is a couple to have a live birth given the baseline conditions of the women? Just for the techniques, do you see my presentation now or not?
Yes.
Yes?
Yes, we see.
Because I only see one party here, but it's okay. Oh, yes, that's okay. So then let me start this in introducing this subject. Predicting models in live birth in IVF ICSI are very important for some reason. The first is making a benchmark comparison between centers. Many centers would like to know exactly what are the performance in terms of live births. And they are not always able to measure it. The patient expectation is of course, is very important, because they would like to know when they start an IVF cycle, how many probability they have to receive a baby. And last question is appropriate treatment, because knowing the chances for a couple to have a live birth, we have sometimes to change the treatment code. Then a lot of models are existing for the moment. Something like 12 models are there, and nobody is using this model. There is a particular reason to that, because this is not very well used for the moment, because these models are difficult to be used. In other words, they are rarely used. I will develop for you today a new option on the particular case of poor ovarian responder. There is no model about that. The proportion of poor ovarian responder is between 10 and 30. Nobody knows exactly, and which depending on the time for the moment, and it seems that it is increasing with time. And because the proportion of live birth is very often very low, the prognosis is, of course, very important, and there is no, for the time, a specific model for these patients. Can I have the next, please? The next slide, please. Hello, yes. So, first of all, what is a poor ovarian responder? There are many different definitions of poor. One of them is the ICSI definition. The two conditions among the first is an age more than 40 years. PNO, just please retain this abbreviation. This is the previous number of oocytes, and PNO less than 3 oocytes. The AFC, antral follicle count, is less than 7, and EMH is less than 1.1 microgram per milliliter. This is a first definition which is very often used in the literature, but as you can see, and as you will see, this definition is not very important and not very good for predicting a live birth. I would just like to remember that a very important study, the name was the SPART study, that was the main author of this study was Dr. Humadin in 2017, which is a very big study in which they have used poor ovarian responder, and they made a selection very close of the S-ray Bologna. We found, in the statistical analysis of this study, we found a very large variability of the number of oocytes and live birth, meaning that even though a patient is considered as a poor ovarian responder, there are many chances that, of course, the probability of live birth should be low, but it is not very possible to predict precisely the live birth proportion. In other words, the Bologna criteria lacks specificity and sensitivity. Then it was necessary to find a prognosis tool needed for poor ovarian responder. And that's what we did in our laboratory of medical statistics in Melbourne. May I have the next slide? Next slide, please. So let me summarize in a nutshell, because we are not here for making statistics, but the objective was to predicting live birth for poor ovarian that was accurate, easy to use in current practice. This is the reason why, Mr. the Chairman, ladies and gentlemen, I'm here for proposing you very easy to use current practice, not difficult, and is a first approach for optimizing precision. Then I would like to be as simple as possible, and of course limited here for the use of folitropin alpha, FSH alpha, during the controlled ovarian simulation course. That's my objective. Can I have the next, please? So, in the next, let me summarize in some way the methods I've used. I started from the SPART data, in which I only use the placebo-controlled subgroup. The N equates 477 patients. We reviewed the predictor list research. We used a non-linear mixed model for calculating the logistic regression. We used center as a random variable. we use a logistic regression with a backward strategy. We attempt a dichotomization in order to make this prediction formula as simple as possible. We use as validity the area under the ROC curve for discrimination, and we use the calibration for the validity. At the end of that, I made an external validity that I will explain you later. So this is, in some words, the statistical analysis that we use together, and we now look at the result. May I have the next, please? The next slide, please. Thank you. Let me summarize the result. To the left, you see all the different predictors possible. Age, P&O is the previous number of sites. As you can see here, the P&O is the logarithm of the P&O. We have also the logarithm of the AMH, the duration of the subfertility, the type of infertility, the number of cycles, the number of live birth previously. And look here, which is very important for all the patients and the non-naive patients, as you can see, only 3 factors are significant. The first is age. And age here is found with a huge, highly significance as a predictor. In the same time, you see that the logarithm of the previous number of oocytes is found as well with very high significance. And the AMH, yes, but as you can see, the previous number of oocytes was found into the subset of the non-naive patients because, of course, it's not possible to calculate the P&O, the previous number of oocytes of patients that are starting from the first time as a IVF cycle. Then what was interesting to show is that age was very significant in the 2 groups, but at the same time, in the group of non-naive patients, the P&O was significant, whereas for all the patients, the AMH was considered as the most significant predictor. From these tables, we will deduce and we will try to find a very good simplification for making a routine practice use for the center. Let me have the next, please. Look, this is the best summary of the predictive model. In using a dichotomy aged more than 40 years, as you can see, I found the first important predictors in showing that if the age is more than 40 years, I reduce tremendously the probability of live birth, something that, of course, everybody was suspecting. For the non-naive patients, I use the previous number of oocytes, P&O. If the P&O is less than 2, this means that the probability of live birth becomes very, very small. And for the patient with non-naive, but all the patients, using an AMH less than 0.5 is also the consequence that the prediction of live birth is very highly reduced. Now, ladies and gentlemen, how can we transform all these scientific findings into a very easy interpretation? Let me do that in the next slide, please. The age is common to both equations. In other words, I will use age. The second condition is the previous number of oocytes and the EMH. As you can imagine, the previous number of oocytes and the EMH are 2 markers of the ovarian reserve. Then, my suggestion was to use 2 conditions. The first is age less than 40 years. The second is either the previous number of oocytes or AMH less than 0.05. And I use 2 conditions. Conditions 1 on age and condition 2 on P&O and AMH. And I suggested and I calculated what we call the prediction model for outcome prediction that I call for abbreviation PROSPER, which is simply the sum of the two conditions 0, 1, and 2. This is something that everybody is able to do that and is able to calculate. And we define a score of baseline severity. 0 is no conditions, 1 is one of the two conditions, age or PNO, and two conditions are the two conditions together, age and PNO and AMH. And let's see an example here on this model. May I have the next slide, please? On this next slide, you will see an example. Look at here for a patient with, you know, the Prosper is divided into 3 scores. 0 is mild, 1 is moderate, and 2 is severe, meaning that 0 mild, meaning that there is no such condition on age, there is no such condition on AMH. 1 is one condition, either age or either ovarian reserve, and 2 is the two together. Let me just make an example based on this part. If you, the mild conditions, I have 27% for the mild, which is of course a very good result of the prediction for a woman for having a live birth. If this is 27 for mild, for a moderate, this is only 9%. And as you can see, this is just divided by 3. For the severe, it is divided by 3, and it is 3%. Just make another example. We start from a mild, which is 18%. If I'm in the moderate case, it is 6%. And if I am the severe, I have 2%. Ladies and gentlemen, in words, this means that live birth reduced to 1/3 for each previous Prosper level. And the second, the live birth is considerably varying with the center. That if you can calculate your value in one center for the mild, 27 for instance, you can directly derive the probability for a moderate and severe patients. Let's go now to the next slide, and let me examine in some way, you know, that when we are doing a predictive model, we have always to make a validation of this model. We did this validation based on 58,000 patients coming from the France, particularly for France, and for the United Kingdom. And as you can see, the IUC, which is an area under the ROC curve, which found that if we are the center, we have continued, for the continuous model, we have 0.8, for the binary model, we have 0.8, and for the Prosper model, which is the very simple model, we have also 0.8, which is a consequence, is that if we are doing that, we can use the Prosper model, which is a very simple model, difficult continuous and binary model. So we can now summarize the result, and let's go to the very final. Let's go to the next slide, please. You will find, ladies and gentlemen, of course, this is just a summary. You will find any details on this model in 3 different papers. The first paper, which was published in 2018. And in this first paper, I outlined and I specified the property of this model. In the second paper, which is predicting live birth for poor ovarian responder, I used the Prosper concept for studying the comparison between the live birth rate for patients using gonal and peg ovaries. And the third, which is now for the moment in submissions at Human Reproduction, which is simply the result, the final result of the external validation. I would like just to go to the very end of my talk. Please, can I have the very last, one of the last slides? Oh, sorry, that's it. We go to the discussion. First of all, my objective was to provide you with a very simple model. A statistician is not there for complicating the use of a predicting model, but of course for simplifying. This model is based only on age, on AMH, and on PNO, which is the previous number of oocytes. This endpoint, this prediction model, is very easily exceeding the precision of the Bologna criteria. If you are using Bologna, we do not have the same precision than for this model. You can use Bologna criteria for binary value. These techniques that I suggest here is prolonging the Bologna into not two different criteria, but in three, in using age or age plus ovarian reserve. And in doing that, I make much more precise the probability of finding the live birth. My choice is a continuous model or an approximation, and I really recommend you to use the very simple Prosper model because it gives you exactly the same precision. And at the end, the good news is that this model is easy, usable, and validated for each center. In other words, this predicting center, this enabler center, you can use that when you receive in written practice, and you can use that in your written practice. I just add this final conclusion that this result provides a simple and accurate tool for predicting live birth in poor ovarian responder. It is needed to compare center performance. This is generalizing to other drugs that should provide an optimal way in the context of optimal drug dispensing. Thank you very much. Thank you for your attention.
Dr. Milotic.
Thank you very much, Professor Lehert. It was very interesting lecture, but how to say, very difficult for me because I'm not so good in mathematics. So I will allow the audience to ask questions maybe. Is there any questions from the audience?
There are no written questions by the audience. If somebody wants to take the floor to raise the hand, if somebody wants to ask. Okay, Professor Timeva. Just a second, and we'll give you the microphone.
Yes. Are you reading me?
Okay, you can ask your question, Professor Timeva.
Okay, thank you very much for this interesting presentation. I just want to ask, because I see in the reference that you put that the one of the study is using your model, predictive model, use recombinant AOH medication for control ovarian hyperstimulation. What is your opinion? Are the statistics change when we use recombinant AOH medication and have a poor ovarian reserve patient? Thank you.
Thank you for your question. During this meeting, it was difficult for me to provide in the same time the benefits of my suggestion in my limitation. And Dr. Timaya, this is a very good idea that you asked me this question, because this takes part of the limitation. My just limitation was that for this moment, this model was very, very recent, because I published this model in 2018, and we are using this model for the moment in WHO, for which I'm a normal consultant, and we had no possibility for the time to compare the validation of this model with the particular topics you are raising, actually. So my suggestion should be this. For the time, I recognize that I cannot answer these questions precisely. Would it be possible that you can provide me your email in the next time, and I will provide you, and I promise you to provide you in the next weeks the validation which is now ready and on which I can answer precisely to the question. Should it be possible that you send me email, and I will send you that my answer as soon as I can. Thank you.
Thank you very much.
Thank you, Professor Lehert. There is another question from the audience, from Jana. She asks, I'm interested, what are the AMH and PON cutoff numbers where the probability of live birth begins to decline?
Yes. Just let me summarize in a nutshell. PNO is then the previous number, and you understand that this PNO is not known for patients that are not have not experienced a first cycle in IVF. In other words, AMH was the second possibility, and when I calculated my predicting model, automatically the result were that the PNO was the very best endpoint. Of course, this is the baseline value, but not all these patients have the PNO. Then I discovered that the AMH and not the AFC was probably the very secondary best predictors. And this was transpiring into my result of the analysis in such a way that I showed that to my colleague investigator, and they say to me, oh, but this is exactly what we would like to expect, because PNO and AMH are simply markers of the reserve, of the ovarian reserve. And we think that if the PNO is existing, we have to use the PNO. If PNO is not existing, we have used the AMH. Once again, this is a limitation of that. We think that the number of patients for which we have the AFC was not enough. And it is our intention to retry to redo this model in using not only the AMH, but also the AFC. And in the next paper that we will do for human reproduction, we will compare the predicting comparability of AMH and AFC and PNO. And we think that at the end, we should be able to totally answer to your question in finding the very best model that should be based on the three together. But again, here, I think that we have something like 80% of precision based on the IUROC, and I think that we can recommend for the moment to use that until a new publication is done. Thank you very much.
There is another question from the audience, from Professor Petya Andreeva. She asked, do you have calculator which you could provide to the reproductive specialists?
Mr. Chairman, can you please repeat the question, please?
The question is, do you have a calculator which you could provide to the reproductive specialists?
Yes, there is one, and in the paper number 1 in 2018, I provide in my appendix in the paper the exact calculator, and I think that should be possible that in our site in the University of Melbourne or in Vain, I will provide to everybody and to everyone should be interested a calculator online. So this calculator will be based on the continuous model, which is of course the most precise one. But for the Prosper model, which is so simple, I have even a possibility to explain to every center how is it possible to calculate the real value of live birth for every center. Because what I am sure, and this is the most important thing, Mr. Chairman, for this talk, which is the live birth is highly dependent on the center. Then every center should be equipped and characterized by a small computer, just Excel or something like that, which is not very difficult, in which we can help the center to calculate the real value of the predictive live birth, and using this model, because at that moment you will find a precision which is exactly 80%. Thank you.
Thank you, Professor Lehert. There are no other written questions. If there is another question from the audience, you could just raise hand.
Okay, thank you.
Well, thank you very much, Professor Lehert. It was a pleasure to be our guest.